Security Assertion Markup Language 2.0 is a version of the SAML standard for exchanging authentication and authorization data between security domains. Saml 2.0 is an XML-based protocol that uses security tokens containing assertions to pass information about a principal between a SAML authority, that is, an identity provider, and a SAML consumer, that is, a service provider. Saml 2.0 enables web-based authentication and authorization scenarios including cross-domain single sign-on, which helps reduce the administrative overhead of distributing multiple authentication tokens to the user. Saml 2.0 was ratified as an OASIS Standard in March 2005, replacing SAML 1.1. The critical aspects of Saml 2.0 are covered in detail in the official documents SAMLConform, SAMLCore, SAMLBind, and SAMLProf. Some 30 individuals from more than 24 companies and organizations were involved in the creation of Saml 2.0. In particular, and of special note, Liberty Alliance donated its Identity Federation framework specification to OASIS, which became the basis of the Saml 2.0 specification. Thus Saml 2.0 represents the convergence of SAML 1.1. Liberty IDFFA 1.2, and Shibboleth 1.3. SAML 2.0 Assertions. An assertion is a package of information that supplies zero or more statements made by a SAML authority. SAML assertions are usually made about a subject, represented by the subject element. The SAML 2.0 specification defines three different kinds of assertion statements that can be created by a SAML authority. All SAML-defined statements are associated with a subject. The three kinds of statements defined are as follows: Authentication Assertion, the assertion subject was authenticated by a particular means at a particular time. Attribute Assertion, the assertion subject is associated with the supplied attributes. Authorization Decision Assertion, a request to allow the assertion subject to access the specified resource has been granted or denied. An important type of SAML assertion is the so-called bearer assertion used to facilitate web browser SSO. Here is an example of a short-lived bearer assertion issued by an identity provider to a service provider. The assertion includes both an authentication assertion SAML, AUTHN statement and an attribute assertion SAML, attribute statement, which presumably the service provider uses to make an access control decision. The prefix SAML represents the SAML v2.0 assertion namespace. Note that in the above example the SAML assertion element contains the following child elements: a SAML issuer element, which contains the unique identifier of the identity provider, a DS signature element, which contains an integrity-preserving digital signature over the SAML assertion element, a SAML subject element, which identifies the authenticated principal, a SAML conditions element, which gives the conditions under which the assertion is to be considered valid, a SAML AUTHN statement element, which describes the act of authentication at the identity provider, a SAML attribute statement element, which asserts a multi-valued attribute associated with the authenticated principal. In words, the assertion encodes the following information. The assertion was issued at time 2004-12-05T092205Z by identity provider regarding subject exclusively for service provider. The authentication statement, in particular, asserts the following. The principal identified in the SAML subject element was authenticated at time 2004-12-05T092200 by means of a password sent over a protected channel. Likewise, the attribute statement asserts that the principal identified in the SAML subject element is a staff member at this institution. SAML 2.0 protocols. The following protocols are specified in SAMLCore: Assertion Query and Request Protocol, Authentication Request Protocol, Artifact Resolution Protocol, Name Identifier Management Protocol, Single Logout Protocol, Name Identifier Mapping Protocol. The most important of these protocols are the Authentication Request Protocol is discussed in detail below. Authentication Request Protocol. In SAML 1.1 web browser SSO profiles are ADP-initiated, that is, an unsolicited SAMLP response element is transmitted from the identity provider to the service provider. In Saml 2.0, however, the flow begins at the service provider who issues an explicit authentication request to the identity provider. The resulting authentication request protocol is a significant new feature of Saml 2.0. When a principal wishes to obtain an assertion containing an authentication statement, a SAMLP, AUTHN request element is transmitted to the identity provider. The above SAMLP, AUTHN request element, which implicitly requests an assertion containing an authentication statement, was evidently issued by a service provider and subsequently presented to the identity provider. The identity provider authenticates the principal and issues an authentication response, which is transmitted back to the service provider. Artifact Resolution Protocol ASAML message is transmitted from one entity to another either by value or by reference. A reference to a SAML message is called an artifact. The receiver of an artifact resolves the reference by sending a SAMLP artifact resolve request directly to the issuer of the artifact, who then responds with the actual message referenced by the artifact. Suppose, for example, that an identity provider sends the following SAMLP artifact resolve request directly to a service provider. In response, the service provider returns the SAML element referenced by the enclosed artifact. This protocol forms the basis of the HTTP artifact binding. SAML 2.0 bindings. The bindings supported by Saml 2.0 are outlined in the bindings specification: SAML SOAP binding, reverse SOAP binding, HTTP redirect binding, HTTP post binding, HTTP artifact binding, SAML URI binding. For web browser SSO, the HTTP redirect binding and the HTTP post binding are commonly used. For example, the service provider may use HTTP redirect to send a request while the identity provider uses HTTP post to transmit the response. This example illustrates that an entity's choice of binding is independent of its partner's choice of binding. HTTP redirect binding, SAML protocol messages are often carried directly in the URL query string of an HTTP GET request. Since the length of URLs is limited in practice, the HTTP redirect binding is suitable for short messages, such as the SAMLP, AUTHN request message. Longer messages should be transmitted via other bindings such as the HTTP post binding. SAML requests or responses transmitted via HTTP redirect have a SAM request or SAM response query string parameter, respectively. Before ETA-unregistered trademark is sent, the message is deflated, base 64 encoded, and URL encoded, in that order. Upon receipt, the process is reversed to recover the original message. For example, encoding the SAMLP, AUTHN request message above yields HTTPS, IDP example org SSO redirect SAML request equals FZFFA8IWFMXFBB9DYXVAJTZ1BQSUROC2, MABBW95IVC5M3TJRXPFFMMLI 3%2F838XJXBCAXTRMEATEJQBDMR%2FRBR-P63K3PL5RPHYOPKVDY, IB%2FCO1%2BC9AYFDQ2WLBGBPZIK9%2FCR7GORYGTWF8P6DKNNWKL%2FWXMAR8S, BHBHJDWZQOKGDS-JMOKG4868S78CTNIZ%2BLP5XPR4D-So1FJOKGMO3IHJCCMZGEF2%2FBK5MNO1F. DGN2JMQPLMHCOB6WTMIVBSCOTF5QV66ZQ2T60XOWXZ2 RKDISC3CWVV1CWJGQANFLO%2BINATX2XL18NK UQPLV-ZR5L%2BVHX-Q-DSA6FWVSZXE63W2ITRTQ2CVRKV2C. The above message may be signed for additional security. In practice, the SAMLP, AUTHN request message is unsigned, leaving the identity provider to identify the sender via SAML metadata. HTTP post binding. In the following example, both the service provider and the identity provider use an HTTP post binding. Initially, the service provider responds to a request from the user agent with a document containing an XHTML form. The value of the SAML request parameter is the base 64 encoding of a SAMLP, AUTHN request element, which is transmitted to the identity provider via the browser. The Sso service at the identity provider validates the request and responds with a document containing another XHTML form. The value of the SAML response parameter is the base 64 encoding of a SAMLP response element, which likewise is transmitted to the service provider via the browser. To automate the submission of the form, the following line of JavaScript may appear anywhere on the XHTML page. This assumes, of course, that the first form element in the page contains the above SAML response containing form element. HTTP artifact binding. The HTTP artifact binding uses the artifact resolution protocol and the SAML SOAP binding to resolve a SAML message by reference. Consider the following specific example. Suppose a service provider wants to send a SAMLP, AUTHN request message to an identity provider. Initially, the service provider transmits an artifact to the identity provider via an HTTP redirect. HTTPS, IDP example org SSO artifact. SAMLart equals artifact. Next, the identity provider sends a SAMLP artifact resolve request directly to the service provider via a back channel. Finally, the service provider returns a SAMLP artifact response element containing the referenced SAMLP AUTHN request message. Of course, the flow can go in the other direction as well, that is, the identity provider may issue an artifact, and in fact this is more common. See, for example, the double artifact profile example later in this topic. Artifact format. In general, a Saml 2.0 artifact is defined as follows. SAML artifact equals B64, typecode equals byte 1 byte 2, endpoint index equals byte 1 byte 2. Thus a Saml 2.0 artifact consists of three components, a 2-byte typecode, a 2-byte endpoint index, and an arbitrary sequence of bytes called the remaining artifact. These three pieces of information are concatenated and base 64 encoded to yield the complete artifact. The typecode uniquely identifies the artifact format. Saml 2.0 predefines just one such artifact, of type E0x0004. The endpoint index is a reference to a particular artifact resolution endpoint managed by the artifact issuer. The remaining artifact, which is determined by the type definition, is the meat of the artifact. The format of a type E0x0004 artifact is further defined as follows. Typecode equals 0x0004, remaining artifact equals sourced message handle, sourced equals 20-byte sequence, message handle equals 20-byte sequence. Thus a type E0x0004 artifact is of size 44 bytes. The sourced is an arbitrary sequence of bytes, although in practice, the sourced is the SHA-1 hash of the issuer's entity ID. The message handle is a random sequence of bytes that references a SAML message that the artifact issuer is willing to produce on demand. For example, consider this hex-encoded type E0x0004 artifact. 000C873F3FD685C833Eb03839D473382055E436913660E3E91759F. If you look closely, you can see the typecode and the endpoint index at the front of the artifact. The next 20 bytes are the SHA-1 hash of the issuer's entity followed by 20 random bytes. The base 64 encoding of these 44 bytes is what you see in the artifact resolve request example above. SAML 2.0 profiles. In SAML 2.0, as in SAML 1.1, the primary use case is still web browser SSO, but the scope of SAML 2.0 is broader than previous versions of SAML, as suggested in the following exhaustive list of profiles: SSO profiles, web browser SSO profile, enhanced client or proxy profile, identity provider discovery profile, single logout profile, name identifier management profile, artifact resolution profile, assertion query request profile, name identifier mapping profile, SAML attribute profiles, basic attribute profile, X500/LDAP attribute profile, UUID attribute profile, DCEPAC attribute profile, XACML attribute profile. Although the number of supported profiles is quite large, the profile's specification is simplified since the binding aspects of each profile have been factored out into a separate binding specification. Web browser SSO profile. SAML 2.0 specifies a web browser SSO profile involving an identity provider, a service provider, and a principal wielding an HTTP user agent. The SP has 4 bindings from which to choose while the IDP has 3, which leads to 12 possible deployment scenarios. We outline 2 such deployment scenarios below. SP post request. IDP post response. This is a relatively simple deployment of the SAML 2.0 web browser SSO profile where both the service provider and the identity provider use the HTTP post binding. The message flow begins with a request for a secured resource at the SP. 1. Request the target resource at the SP. The principal requests a target resource at the service provider. https sp.example.com/myresource. The service provider performs a security check on behalf of the target resource. If a valid security context of the service provider already exists, skip steps to a 7. 2. Respond with an XHTML form. The service provider responds with a document containing an XHTML form. The relay state token is an opaque reference to state information maintained at the service provider. The value of the SAML request parameter is the base 64 encoding of the following SAMLP, AUTHN request element. Before the SAMLP, AUTHN request element is inserted into the XHTML form, it is first base 64 encoded. 3. Request the SSO service at the IDP. The user agent issues a post request to the SSO service at the identity provider. Post SSO post http:/1.1, host, idp.example.org, content type, application XWWW formal encoded, content length, NNN, SAML request equals request and relay state equals token. Where the values of the SAML request and relay state parameters are taken from the XHTML format step 2. The SSO service processes the SAMLP, AUTHN request element and performs a security check. If the user does not have a valid security context, the identity provider identifies the user. 4. Respond with an XHTML form. The SSO service validates the request and responds with a document containing an XHTML form. The value of the relay state parameter has been preserved from step 3. The value of the SAML response parameter is the base 64 encoding of the following SAMLP, response element. 5. Request the assertion consumer service at the SP. the user agent issues a POST request to the assertion consumer service at the service provider. POST SSO POST HTTP/1.1, host, sp.example.com, content type, application XWWW formal encoded, content length, NNN, SAML response equals response and relay state equals token. Where the values of the SAML response and relay state parameters are taken from the XHTML format step 4. 6. Redirect to the target resource. The assertion consumer service processes the response, creates a security context to the service provider and redirects the user agent to the target resource. 7. Request the target resource at the SP again. The user agent requests the target resource at the service provider. https sp.example.com/myresource. 8. Respond with requested resource. Since a security context exists, the service provider returns the resource to the user agent. SP redirect artifact. IP redirect artifact. This is a complex deployment of the Saml 2.0 web browser SSO profile where both the service provider and the identity provider use the HTTP artifact binding. Both artifacts are delivered to their respective endpoints via HTTP GET. The message flow begins with a request for a secured resource at the SP. 1. Request the target resource at the SP. The principal requests a target resource at the service provider. https sp.example.com/myresource. The service provider performs a security check on behalf of the target resource. If a valid security context at the service provider already exists, skip steps to €11. 2. Redirect to the single sign-on service at the IDP. The service provider redirects the user agent to the single sign-on service at the identity provider. A relay state parameter and a SAMLart parameter are appended to the redirect URL. 3. Request the SSO service at the IDP. The user agent requests the SSO service at the identity provider. https idp example org SSO artifact. SAMLart equals artifact 1 and relay state equals token. Where token is an opaque reference to state information maintained at the service provider and artifact 1 is a SAML artifact, both issued at step 2. 4. Request the artifact resolution service at the SP. The SSO service dereferences the artifact by sending a SAMLP artifact resolve element bound to a SAML SOAP message to the artifact resolution service at the service provider. Where the value of the SAMLP artifact element is the SAML artifact transmitted at step 3. 5. Respond with a SAML AUTHN request. The artifact resolution service at the service provider returns a SAMLP artifact response element bound to a SAML SOAP message to the SSO service at the identity provider. The SSO service processes the SAMLP AUTHN request element and performs a security check. If the user does not have a valid security context, the identity provider identifies the user. 6. Redirect the assertion consumer service. The SSO service at the identity provider redirects the user agent to the assertion consumer service at the service provider. The previous relay state parameter and a new SAMLart parameter are appended to the redirect URL. 7. Request the assertion consumer service at the SP. The user agent requests the assertion consumer service at the service provider. https sp.example.com SSO artifact. SAMLart equals artifact 2 and relay state equals token. Where token is the token value from step 3 and artifact 2 is the SAML artifact issued at step 6. 8. Request the artifact resolution service at the IDP. The assertion consumer service dereferences the artifact by sending a SAMLP artifact resolve element bound to a SAML SOAP message to the artifact resolution service at the identity provider. Where the value of the SAMLP artifact element is the SAML artifact transmitted at step 7. 9. Respond with a SAML assertion. The artifact resolution service at the identity provider returns a SAMLP artifact response element bound to a SAML SOAP message to the assertion consumer service at the service provider. 10. Redirect to the target resource. The assertion consumer service processes the response, creates a security context at the service provider and redirects the user agent to the target resource. 11. Request the target resource at the SP again. The user agent requests the target resource at the service provider. https://sp.example.com/myresource. 12. Respond with the requested resource. Since a security context exists, the service provider returns the resource to the user agent. Identity Provider Discovery Profile. The Saml 2.0 Identity Provider Discovery Profile introduces the following concepts: Common Domain Cookie, Common Domain Cookie Writing Service, Common Domain Cookie Reading Service. As a hypothetical example of a common domain, let's suppose example UK and example Deutschland belong to the virtual organization example Global Alliance. In this example, the domain example.com is the common domain. Both example UK and example Deutschland have a presence in this domain. The common domain cookie is a secure browser cookie scoped to the common domain. For each browser user, this cookie stores a history list of recently visited IDPs. The name and value of the cookie are specified in the IDP discovery profile. After a successful act of authentication, the IDP requests the common domain cookie writing service. This service appends the IDP's unique identifier to the common domain cookie. An SP, when it receives an unauthenticated request for a protected resource, requests the common domain cookie reading service to discover the browser user's most recently used IDP. Assertion Query Request Profile. The Assertion Query Request Profile is a general profile that accommodates numerous types of so-called queries using the following Saml 2.0 elements: the SAMLP, Assertion ID Request Element, which is used to request an assertion given its unique identifier, the SAMLP, Subject Query Element, which is an abstract extension point that allows new subject-based SAML queries to be defined, the SAMLP, AUTHN Query Element, which is used to request existing authentication assertions about a given subject from an authentication authority, the SAMLP, Attribute Query Element, which is used to request attributes about a given subject from an attribute. Authority, the SAMLP, AUTHZ Decision Query Element, which is used to request an authorization decision from a trusted third party. The SAML SOAP binding is often used in conjunction with queries. SAML Attribute Query. The attribute query is perhaps the most important type of SAML query. Often a requester, acting on behalf of the principal, queries an identity provider for attributes. Below we give an example of a query issued by a principal directly. Note that the issuer is the subject in this case. This is sometimes called an attribute self-query. An identity provider might return the following assertion, wrapped in a SAMLP response element. In contrast to the bearer assertion shown earlier, this assertion has a longer lifetime corresponding to the lifetime of the X509 certificate that the principal used to authenticate the identity provider. Moreover, since the assertion is signed, the user can push this assertion to a relying party, and as long as the user can prove possession of the corresponding private key, the relying party can be assured that the assertion is authentic. SAML 2.0 Metadata. Quite literally, metadata is what makes SAML work. Let's look at some important uses of metadata. An identity provider receives an SAMLP, AUTHN request element from a service provider via the browser. How does the identity provider know the service provider is authentic and not some evil service provider trying to fish private information regarding the user? The identity provider consults its list of trusted service providers in metadata before issuing an authentication response. In the previous scenario, how does the identity provider know where to redirect the user with the authentication response? The identity provider looks up a prearranged endpoint location of the service provider in metadata. How does the service provider know that the authentication response came from a trusted identity provider? The service provider validates the signature on the assertion using the public key of the identity provider from metadata. How does the service provider know where to resolve an artifact from a trusted identity provider? The service provider looks up the prearranged endpoint location of the identity provider's artifact resolution service for metadata. Metadata ensures a secure transaction between an identity provider and a service provider. Before metadata, trust information was encoded into the implementation in a proprietary manner. Now the sharing of trust information is facilitated by standard metadata. Saml 2.0 provides a well-defined, interoperable metadata format that entities can leverage to bootstrap the trust process. Identity provider metadata. An identity provider publishes data about itself in an MD, entity descriptor element. The entity it attributes is the unique identifier of the identity provider. Note that the details of the digital signature have been omitted from this example. The identity provider manages an Sso service and an attribute authority, each having its own descriptor. We describe Sso service metadata below while the MD, attribute authority descriptor element is not shown. Sso service metadata, the Sso service at the identity provider is described in an MD, IDPSA descriptor element. The previous metadata element describes the Sso service at the identity provider. Note the following details about this element: key information has been omitted for brevity. The binding attribute of the MD, artifact resolution server key, element indicates that the SAML binding should be used for artifact resolution. The location attribute of the MD, artifact resolution server key, element is used in step 8 of the double artifact profile. The value of the index attribute of the MD, artifact resolution server key, element is used as the endpoint index in the construction of a SAML type E0x0004 artifact. The MD, name-ID format elements indicate what SAML name identifier formats the Sso service supports. The binding attributes of the MD, single sign-on service elements are standard URIs specified in the Saml 2.0 binding specification. The location attribute of the MD, single sign-on service element that supports the HTTP post binding is used in step 2 of the double post profile. The location attribute of the MD, single sign-on service element that supports the HTTP artifact binding is used in step 2 of the double artifact profile. The SAML attribute element describes an attribute that the identity provider is willing to assert. The SAML attribute value elements enumerate the possible values the attribute may take on. Service provider metadata. A service provider also publishes data about itself in an MD, entity descriptor element. The primary component managed by the service provider is the Assertion Consumer Service, which is discussed below. Assertion Consumer Service Metadata. The Assertion Consumer Service is contained in an MD, SPSA descriptor element. Note the following details about the MD, SPSA descriptor metadata element. The index attribute of an MD, Assertion Consumer Service element is used as the value of the Assertion Consumer Service index attribute in a SAMLP, AUTHN request element. The binding attributes of the MD, Assertion Consumer Service elements are standard URIs specified in the Saml 2.0 binding specification. The location attribute of the MD, Assertion Consumer Service element that supports the HTTP post binding is used in step 4 of the double post profile. The location attribute of the MD, Assertion Consumer Service element that supports the HTTP artifact binding is used in step 6 of the double artifact profile. The MD, attribute consuming service element is used by the identity provider to formulate an SAML attribute statement element that is pushed to the service provider in conjunction with web browser SSO. The index attribute of the MD, attribute consuming service element is used as the value of the Assertion Consuming Server Key index attribute in a SAMLP, AUTHN request element. As noted earlier, The values of the location attributes are used by an identity provider to route SAML messages, which minimizes the possibility of a rogue service provider orchestrating a man-in-the-middle attack. Metadata aggregates. In the previous examples, each MD, entity descriptor element is shown to be digitally signed. In practice, however, multiple MD, entity descriptor elements are grouped together under an MD, entities descriptor element with a single digital signature over the entire aggregate. Typically metadata aggregates such as this are published by trusted third parties called federations who vouch for the integrity of all the metadata in the aggregate. These metadata aggregates can be very large, sometimes on the order of hundreds of entities per aggregate. See also, SAML, SAML 1.1, SAML-based products and services, references.